Hi everyone. Okay, so continuing continuing our discussion about functions. A function is continuous over an interval of its domain if its hand-drawn graph over that interval can be sketched without lifting the pencil from the paper, right? So that's basically how we determine if a function is continuous, if you can draw it without ever lifting your pen. So basically that means the graph cannot have any holes or gaps in it. So it says determine the intervals of continuity for each function. Notice from the vertical line test, they are indeed both functions. And so this one, I can follow it along and remember our intervals for continuity, increasing, decreasing, have to do with the x values. When is it continuous? So the function, the y, is continuous over these x values. So if I'm going along my x-axis, I come to negative infinity, and then it's a continuous line until I get to when x is 3. Okay. Or on the other side of 3, so starting at 3, all the way to infinity. This one, if I'm thinking about the x's, I'm going along, an arrow, and it is continuous over its entire domain. So negative infinity to negative infinity. Okay, continuity. Now these are our basic functions. Notice, think about the vertical line test. Every one of these is a function. This, don't think this isn't a straight line. This is varying over, verging over slightly, slightly, slightly over as it goes up. Okay. And these functions right now, we want to get to know their properties. So you'll be asked questions now about their properties and things, but get used to the shapes of these functions before we start our next lesson, because we're going to really delve into graphing these functions. So this is the function, well, they're written right up here, but I was going to write it down here too. Y equals x, right? They've used function notation, but if I'm graphing, I like it to be x and y, so it's very obvious what my coordinates are. So this is the graph of y equals x. Okay, so in this section of homework, you're going to be asked just a few questions about these graphs. What's its domain? This one is domains negative infinity to negative infinity. Range is the same. These kinds of things. This is the graph of y equals x squared. So this is what quadratic functions look like. Okay, so for the basic function, notice its range now is 0 to infinity. This is a cubic graph. Y equals x cubed. This is a radical graph. Y equals square root of x. This is a cube root. Y equals the cube root. Notice it's this graph laid over on its side, right? So x cubed, cube root of x. This one's the absolute value of x. This graph and this graph are related. Notice if we turn this graph over on its side, right, here's half of it. The reason that we can't have the whole shape turned on its side is it's no longer a function. This is what the graph of y squared equals x looks like, right? Which is not a function, not a function. So these two are related, but we have the square root of x that keeps it a function. These two turned over on its side. And then absolute value of x. Once again, if we had the absolute value on the y, it would look like this, which is not a function. Okay, notice that the absolute value graph has a point, and this is more like a U. So we need to get used to that when we're drawing them in the future. And I want to pay attention to my properties and my shapes of these graphs and know these shapes before we start next time. Okay, so before we start with our basics then, which we'll do next time, just another kind of function we're going to get out of the way, kind of like we did circles, because they're kind of an isolated area themselves, are piecewise functions. Notice it's a function, right? It's telling us that they're functions, meaning they're going to pass the vertical line test, but it's in pieces. So all I need to do to graph these things is graph each piece individually. Okay, so first I'm going to do this piece, and I see it's a line. So if we're good at our linear functions, we can use a couple of ways to graph these. I'm just going to plug in points because I've got a restriction on my domain. This graph is only to be graphed when x is less than or equal to 2. So I might put a few points in here, like 0, 1, and 2, right? And then find corresponding parts for my y value. So if x is 0, 0 plus 5 is 5. If x is 1, negative 2 plus 5 is 3. If x is 2, negative 4 plus 5 is 1. And I can plot these points. 0, 5. Let me try to get us a axis going here so we can tell what's going on. I hope that's more helpful than less helpful. We'll see. Okay, so I'm going to plot these points, 0, 5, and maybe I will even go by 2s. 2, 4, negative 2. Okay, so 0, 5, 1, 3, and 2, 1. Okay, so when x is less than or equal to 2, so I know it's a line, right? It's a linear function, so I just got to know that shape is a line. Goes forever. Let's draw the other piece. I'm going to do it in different color just for to be obvious what we're doing. Now I want numbers greater than 2. Now I'm going to, actually I'll do it in black, I'm going to use 2, but at 2, because if I just started with 3, all of these parts of the graph in between wouldn't be graphed. So, you know, I could put in like 2.001, but I can just start at 2, okay, and 3. So I put that in a different color just to remind myself that that point is not actually on the graph. But greater than 2, let's put another couple of points. So if x is 3, 3 plus 1 is 4. If x is 4, 4 plus 1 is 5. Let's plot these points. Now, this point right here, because it's not actually, doesn't have the equal part, when I plot this point, I'm going to make it a whole, right? So if x is 2, then y is 3, so a whole. Notice also, if that was a point, this would all of a sudden not be a function because I'd have a vertical line I could draw right through there. So we got to pay attention to whether the end point is included or not included. And then 3, 4, and then 4, 5. So piecewise function drawn there. All right? So what we're going to do is we're just going to take each piece, plot a few points, and just draw that piece, paying attention to whether the endpoints are included or not. Okay, here's another one. Okay, so for the first piece, it's a line. Notice the second piece is going to be a parabola. So that's another reason I need to know the shapes of these graphs so I know, you know, when I have a few points, what kind of shape I'm trying to fit into it. So x less than or equal to 0. So let's just say negative 2, negative 1, 0 for my x's. If I plugged in a -2, -4 plus 3 is -1. If I plugged in a -1, -2 plus 3 is +1, and then 0 plus 3 is 3. I'm going to go ahead and see what values I need for this piece so that I'll know how I need to draw my my scale. All right, now this is greater than or equal to 0. So once again, just to remind me, this is not actually on the graph, but I want to go right up to that point of 0. So if x is 0, 3. Okay, and then if x is 1, okay, remember this isn't -1 squared, it's -1 squared. It would be in parentheses if that square had anything to do with that negative. So I'm plugging in 1, so that's 1 squared, 1, -1 plus 2. I'm sorry, -1 plus 3 is 2. Okay, 4, so -4 plus 3 is -1. I can just leave this scale as 1s. Oh, I thought I was going to have an actual straight line there. I was so impressed for a minute. I don't know how that even happened. Okay, so let's plot these points. So -2, -1, okay, -1, +1, and 0, 3. All right, since we're going less than, everything less than, that's what tells me to draw my arrow in this direction, right? Because this is everything less than 0. Okay, now I've got 0, 3. Now technically on this, it's an open circle on the green part, but notice that my other line has filled it in. So this would actually make a continuous function once it's drawn, but it would still be a function. There would only be one value associated with that point. And then 1, 2, and then 2, -1. Now what's important about this is recognizing the shape, right? I said you gotta know those shapes and properties of those basic functions. And because this is a square, and I've got a couple of points, then I know to draw the shape in kind of as an upside down U thing. Make it a U. Don't try to make it a straight line. Okay. All right, let's do that one more time. Oh, this time I've got 3 sections. Let's see, they're all lines though, so we're good with that. If x is less than 3, so what do you say? 1, 2, 3. But let's make ourselves a note that not actually going to put the 0.3 on there. We'll have a hole there. So -2 times 3 is -6. Okay. And then -2 times 1 is -2. -2 times 2 is -4. Once again, I'm going to find my values here so I know how to adjust my scale. So I'll do the second one here. Okay, and this is if x is, and each endpoint is included, -3 to 2. So -3, -2, -1, 0, 1, 2. Okay, lots of values for this one. And you don't have to do every value. You might do -3, -1, 2. You know it's a straight line just because it's a straight line. If this was a square, I'd want all these values to see how my curve fits. If it goes out like this or up like this, right? But if it's a straight line, 2 or 3 points is enough. Actually, the 2 endpoints is probably enough. That may be what I do here. Okay, so plugging in -3. So -9 minus 1, we get -10. Okay, let's do 0. It's an easy one. So 0 minus 1 is -1. And then plugging in the 2, I gotta have my endpoints. So 6 minus 1 is 5. Okay, now let's do that end piece. And this is for numbers greater than 2. So maybe 2, 3, 4, 5. Okay, greater than 2. Negative 4 times 2 is negative 8. And then, okay, negative 4 times 3 is negative 12. Negative 4 times 4 is negative 16. All right, so when I do my scale over here, let's see. Bunch of negatives, oh, they're all negatives? Then let's draw our axis way up here. 2, 4, 6, 8, 10, 12. Yeah, and let's go by 2s. All right, just so it'll fit. Nice. Okay. These points. 1, negative 2. 2, negative 4. And then 3, negative 6, but that's a hole, right? An open circle. Now, this is for everything less than 3. So that's what tells me, oh, I need to draw my arrow this direction. Oh, you know what? Look at this. I bet this is supposed to be, because I was just saying this is not going to work. There's a typo in here. That is supposed to be negative 3 because I can't have a piece of my graph here, right? And then from negative 3 to 2, I'm going to have another line and then greater than 2. No, no, that's supposed to be negative 3. Notice how my domain needs to go from negative 3, 0, negative 3, then to 2 and up. All right, so let's redo that one. Keeping in mind that this should have been negative 3. Come on, this should be negative 3. Okay, so less than negative 3. Okay, so that's going to be like negative 3, negative 4, negative 5. Okay, so if I plug in a negative 3, oh, I'm going to have to change my whole scale. Negative 2 times negative 3 is positive 6. Okay, but I'm not actually going to plot that as a point. It'll be a hole. Okay, and then let's say negative 4 and negative 5, less than negative 3. So negative 2 times negative 4 is positive 8, and negative 2 times negative 5 is positive 10. All right, so we'll have to go back and redo my scale. I thought that worked out a little too nicely with them all being negatives. Whoops. Whoa, I did it again for at least a section. Woohoo. Okay. Okay, green. All right, so I've got negative 3. Oh, well, let's figure out what scale we're going to do. We're going from basically 10 to negative 16. That's probably off. So let's make these go by 3s. How about that? 3, 6, 9, 12, negative 3. Okay. All right, so we've got negative 3 and 6, but that's a hole. Okay, and then we've got negative 4 and 8, and negative 5 and 10. All right, so here's that piece. Okay, then we've got negative 3 and 10. 0 and negative 1. Wait. Negative 1 and negative 10. All right, so negative 3, negative 10. 3, 6, 9, negative 10. 0, negative 1. And 2, positive 5. Because it's a straight line, right? I don't have to have every point in between there. Let's imagine that I can kind of draw a straight line. That one wasn't too bad. Not bad. Okay. And then we've got 2 and negative 8. 3, 6, 9. So, but remember, it's a whole. And then we've got 3 and negative 12. 3, 6, 9, 12. And then 4 and negative 16. 3, 6, 9, 12, 15. So it looks like this. Okay, and it's still a function because there's a vertical, there's only one point where it actually crosses the graph, but it's not continuous, right? Discontinuous. Okay, so graphing piecewise functions. Just do each piece and pay attention to whether you have a whole or an actual point at the end point. Okay, I'll see you next time. Let me know if you need anything.